Dear students, how are you today? I hope you're fine. Angle relationships in triangles, lesson 2 on chapter 4. By the end of the lesson, you'll be able to find the measure of interior and exterior angles of triangles, apply theorems about the interior and exterior angles of triangles. So, first of all, I have here this triangle sum theorem. The sum of angle measures of a triangle, the sum of angle measures of a triangles, equals to 180 degree. So measure A plus measure B plus measure C will give you 180 degrees. Okay. Here for this example, a surveying application. Okay, the map of France, commonly used in 1600, was significantly revised as a result of triangulation land survey. The diagram shows part of the survey map. Use the diagram to find the indicated angle measures. So I have here this map. I have here he needs me to find measure of angle, what nkm, n, okay, focus here, nkm, the red one here. Okay, and I have here, what can you see, this triangle, this shaded triangle, 88 degrees and 48 degrees is given, and I have some missing one. So it's what we will use. What we will use this that we will use this one, 88 plus 48, 88 plus 48, and the sum of them will be subtracted from 180 degrees to find that the last one will be 44 degrees, of course, right? Okay, so I have here to add 88, okay, again, to add 88 degrees plus 48 degrees and 180 minus the sum of 88 plus what, 48, okay, degrees. Okay, so it gives me the answer, which is 44 degrees. Okay, I can solve it by this way, or I can write it 88 plus 48 plus nkm gives me 180 degrees. Okay, then I add them. This is the steps in details, so I'll add them. 136 plus nkm equals to 180. So here 180, I'll subtract 136 from both sides, so measure nkm gives you 44 degrees. Okay, this is in more details. I have here a measure jlk. Let's see measure jlk. J, it's very easy, I know. Okay, J, okay, L, I want to see the whole graph, the whole map here, jlk. So this is jlk. How can I solve this one? Okay, I have here 70 degrees for LJK. Okay, want to show you LJK, this one, the marker LJK, 70 degrees is given. Okay, and I have calculated this one, 44. Remember this one, don't forget to write this one. So you have here 44, and we have here what? We have here supplementary. So 44, 100 plus 104, okay, 180 minus 44 plus what, plus 104 gives you this one, the small here angle, okay, which is the angle of LKJ. Okay, so let's see together. Okay, here step 1, find the angle JKL. So I have here NKM plus measure angle MKJ plus measure angle JKL equals 180. Okay, I have here, that's what I was talking about. So I found the angle is 32 degree. How? I added 44 plus 104 gives me 148. Okay, and then I subtracted 148 from both sides, from 180 and from 148. So measure JKL alone gives me 32 degrees. Okay, so I got here this angle 32. This is 32 degrees, right? 32, and you have the 70 degrees, so this one is okay. I have 180 degrees minus the sum of 32 and 70 degrees. We can see it in more details to be sure that we can solve it. So use the substitution, then solve for JLK. So I have here, as I told you, a measure of angle JLK plus 32 plus 70 gives you 180 degrees. So the sum of them 102. So I subtract both sides by 102. So 180, this one minus 102 gives you what? 78 degrees. Okay? Okay. So I have here corollary. Corollary is a theorem whose proof follows directly from another theorem. Here are two corollaries to the triangle sum theorem. I have here corollary. I have the acute angles of the right triangle are complementary. We have here 90 degrees, so the sum of here angle FDE and the angle here FED are 90 degrees. Okay, they are complementary. Remember, complementary. Okay, the measure of each angle in a equiangular triangle is 60 degrees. As I have here, the sum of all angles are 180, so the sum of each angle here 180 divided 3 gives you 60 degrees. 180 divided 3 angles, as you see, gives you 60 degrees. This is corollary. Corollary theorem. Okay, corollary is a theorem whose proof follows directly from another theorem. Okay, so here this example 2, finding angle measures in right triangles. One of the acute angles in a right triangle measures 22.9 degrees. What's the measure of the other acute triangle? You have right triangle 90 degree and you have 22.9 degrees, so the remaining angle will be 67.1 degrees. So we added here, it's very easy, I know for you, we added here measure M plus measure N, it gives you 90 degrees. And I have here as you see, I have here if we have here this right triangle, okay, this right triangle again, okay, to make it more accurate. Okay, as you see this right triangle, I have this 90 degree, okay, and I have one of the angles gives me 22.9, and I need to find this one. This is very easy, okay, because you have here the sum of two other angles here are 90 degrees. They are complementary. Okay, 90 degree minus what? 22.9. So the answer would be 90 degree minus 22.9. Easy one. Yes, let's go. Okay, moving to the interior is the set of all points. Okay, moving to this point. The interior here is the set of all points inside the figure. Okay, interior, inside. The exterior is the set of all points outside the figure. An interior angle is formed by two sides of the triangle. An exterior angle is formed by one side of the triangle and the extension of an adjacent side. Each exterior angle has two remote interior angles. A remote interior angle is an interior angle that's not adjacent to the exterior angle. Okay, as you see here, the interiors here I have interior angles 1, 2, and 3 interior angles. The exterior here is 4, is an exterior angle. Its remote interior angles are 1 and 2. Okay, so I have here exterior angle theorem. The measure of an exterior angle of a triangle is equals to the sum of the measures of its remote interior angle. So I have here measure of angle, okay, in this way it will be easier for you. I have here measure 4. Can you see measure 4 is equal to measure 1 plus 2? So again, I have here measure 4, this one, the exterior angle, it's equal to the sum of of measure 1 and 2. Okay, okay. Applying the exterior angle theorem, find measure of angle J. Where is J? Let we see J together. I have here, yes, this J. So, and J, it's what here? It's given as what, an equation. Wow. So I have here find measure angle J. I know that measure angle J plus measure angle what? Yeah, plus measure angle H gives me angle what? Angle, the exterior angle here, which is FGH, which is also 126 degree. So I have here two equations, 5x plus 17, and I have 6x minus 1. The sum of them gives me what? Gives me 126, and this is the exterior yes theorem. So after putting them beside each other, okay, I can here put the like terms together. 6x plus 5x gives me 11x, and I have here 17 minus 1, 16, and 126 as it is. I want to get rid of the 16, so subtract both sides by 16 gives you 11x equals to 110. Then I want to get rid of the coefficient of x here, which is 11. 11 divided 11 gives you x, and 111, this one, divided by 11 gives me 10. So I have here x for 10. Can we substitute or solve for 10 instead of x? It's right. So 5x plus 17, 5x plus 17, which is the measure of, remember, J, right, gives me what? 67 degrees. Okay, so we have solved the problem very easy. Okay, I have here another theorem, third angles theorem. Third angle theorem. Okay, if two angles, okay, want the marker. Okay, I have here, I don't know where the marker goes from me. Okay, I have here, if two angles of one triangle are congruent, okay, to two angles of another triangle, then the third pair of angles are congruent. Thank you, it's very easy. Okay, it's by logic. You have here this sign and this sign with two dashes here, or two arrows. Okay, small curves like this, two like this. Okay, means that they are congruent, and just one here the same as this one, congruent. Okay, when you have two angles like this are congruent to the other two angles inside the another triangle, the third one, of course, the third pair of angles are congruent. Okay, so T and N here, T and N are congruent here. So T and N will be congruent, as R, S, we have here R, S, and L, M are congruent, so T, N are congruent. So this is the theorem of, yes, of third angles theorem. Okay, applying the third angles theorem quickly because it's very easy. I have here to find measure of angle, find angle C and angle also F. Okay, let's see here. Angle, okay, come. I have to find angle C and angle F. C, this one, y power 2, y to the second power, and angle F, which is, yeah, equation here 3, y to the second power minus 72 degrees. So I have here, what do you think what I have here? E, measure of angle E, it's equal to measure of angle B, 90 degree, and I have D equals to measure of angle A. So what do you think I have here? What I have here, the third theorem, yes, the third theorem, which gives me that C equals to here F. When C equals measure F, I have here y power 2 equals to Yes, substitute here y to the second power for measure c, and 3 to the power 3y to the power 2, this one I'm talking about, this one, minus 72 for measure of angle f. So let's solve for this, simplify this equation now. So you have here what, my dear students? I have here two solve for the like terms. I have here 3y to the second power and y to the second power. So 3y to the second power, and we will solve for this. I will do what? I will subtract. Okay, I'm sorry. I'll subtract 3y to the second power from both sides. Okay. Okay. So when I say here y to the second power, okay, minus this one, y to the second power minus what? Minus 3y to the second power gives you what? Yeah, gives you negative 3. When I say negative 3, okay, when I say negative 3 here, and positive 1y gives you what? Negative 2y to the second power, because here we have a hidden 1y to the second power minus 3y to the second power gives you what? Yes, negative 2. Excellent. Okay, I know that you are smart. So I have here what? I have here negative 2y to the second power equals to negative 72. What should I do now? I have to isolate here y to the second power. So what should I do? Divide the coefficient here by negative 2 to get rid of this negative 2. So y power 2 equals negative 72. Okay, divided by what? Negative 2. Negative, positive, and 72 divided by 2 gives you 36. Okay, so my answer will be 36 for measure of C. Okay, and I have here 36 for measure of C, and I have here measure F equals to measure C, so measure F will be 36. Okay. Okay, dear students, go back to your practice book and solve the worksheet on this lesson. Thank you, my dear students. Bye bye.